Imagine waking up in the middle of the night, to a sky so bright it feels like morning. A massive glowing sphere dominates the heavens, far larger, far brighter, and far more terrifying than anything humanity has ever seen. It is the moon, but not the moon we know. This moon hangs 10 times closer to Earth, a gravitational monster capable of reshaping the world in a single night. This is not a myth or a fantasy. This is the raw, unforgiving power of physics pushed to its limits. And if the moon ever drifted that close, everything about Earth, its oceans, its land, its atmosphere, its stability, would change forever. Today, we explore what would happen if the moon came 10 times closer to Earth. To understand this scenario, we must begin with distance. The moon normally rests about 384,000 kilometers away. Bringing it down to 38,000 kilometers would make it appear 100 times larger in our sky. Nights would look like permanent twilight. Shadows would stretch in ways humans have never seen. The stars would fade behind the overwhelming glow of a giant lunar disk, filling nearly half the sky. But the real danger wouldn't be brightness. It would be gravity. A moon 10 times closer doesn't pull 10 times harder. It pulls 1,000 times harder. Every force it exerts today would become a force of destruction. The tides it gently lifts would turn into catastrophic walls of water. The slight tug it exerts on Earth's crust would become powerful enough to break continents. Let's explore what such a world would be like. The first and most immediate change, the tides. Today, typical tides rise by a meter or two, but with a moon 1,000 times stronger, tides would soar to impossible heights. Imagine waves stretching hundreds of feet tall, sweeping across coastlines, swallowing cities, and erasing entire nations in minutes. Places like New York, London, Shanghai, Dubai, and Tokyo would vanish beneath unstoppable ocean surges. The map of Earth would redraw itself within hours. But the oceans wouldn't be the only victims. The Earth's crust would begin to stretch and twist under the moon's amplified gravity. Earthquakes would ripple across the globe, fault lines would snap, volcanoes would awaken, dormant ones would erupt violently, while new volcanic vents would tear open across the land. Earth would become a planet of constant seismic terror, shaking and groaning under the pressure of its too powerful neighbor. Meanwhile, the moon itself would begin to suffer. At 38,000 kilometers, it would enter the Roche limit, the boundary where Earth's gravity becomes strong enough to tear the moon apart. Cracks would spread across its ancient surface, lava oceans would leak into space, the moon would slowly break into a stream of glowing fragments. Within days, Earth would gain rings, beautiful, shimmering rings made of lunar debris. But this beauty would quickly become deadly. Not all those fragments would remain in orbit. Huge pieces, some as large as mountains, would fall toward Earth. They would blaze into the atmosphere as firestorms, crashing into oceans, plains, and mountains. Each impact would unleash the power of thousands of nuclear bombs. Dust and ash would rise into the sky, blocking sunlight. Temperatures would fall, crops would fail. The world would enter a new age of cold and darkness. To understand this devastation, it helps to look at examples from elsewhere. Jupiter's moon Io is the most volcanic object in the solar system, not because of internal heat, but because Jupiter's gravity stretches and squeezes it constantly. Earth, under the pull of a moon 10 times closer, would become similar to Io, unstable, violent, unpredictable. Even Earth's tilt, responsible for our seasons, would become unstable. Without the moon's distance keeping it stable, Earth could wobble wildly, causing sudden climate swings, extreme weather, and global climate collapse. The balance that makes Earth habitable would be destroyed. Now let's walk through the scenario step by step, from the moment the moon begins its fatal approach. The sky brightens instantly as the moon grows larger. Animals panic, ocean tides rise within hours. At first they surge like superstorms, then they grow into towering walls of water, sweeping far inland, dragging entire regions into the sea. Earthquakes begin next. They strike without warning, tearing apart cities. Buildings collapse, infrastructure fails, bridges twist, power grids overload. Humanity finds itself in chaos. As the moon reaches the Roche limit, the most violent stage begins. The lunar surface shatters. Rivers of molten rock spill into space. A glowing ring begins to form around Earth. Spectacular but deadly. Soon after, debris begins to fall. Fireballs streak across the sky, crashing into continents, igniting forests, vaporizing oceans, and sending shockwaves across the globe. Darkness spreads. Cold settles in. The world enters a survival crisis. Eventually, after the impacts slow and the tides settle, what remains of the moon stabilizes into a permanent ring system. Earth becomes a ringed world, breathtaking but scarred forever, a world where coastlines have shifted, continents have cracked, and ecosystems have collapsed. Life would still exist, but civilization as we know it would be gone. This scenario reveals a truth often forgotten. The moon is not just a beautiful companion in our night sky. It is a stabilizer, a protector, a guardian. Its distance is perfect, not too close, not too far. A change of even a few percent affects tides and climate. A change of 10 times would destroy everything. The moon keeps Earth calm, balanced, alive. So the next time you look up at it, remember, its distance is not a coincidence. It is the reason life thrives on this planet. And with that thought, one final question remains. If bringing the moon closer can destroy the world, what would happen if the moon disappeared entirely? A mystery for another time and another what if.